Okay, so today we're going to get the closest that we ever get in this class to biology. And before you start freaking out about this, I promise that this part of biology is not 100% boring, no matter whatever you think of the rest of biology. This part, I promise, is awesome. And Noah, you can tell Mrs. Williams I said that. All right, so here's what we're going to do. Draw a schematic of an eyeball. Now, this is not going to be a schematic of what a real eyeball looks like because, again, your biology teachers can tell you more about it than I can. But I'm going to draw what I think are the most interesting parts of the eyeball. This part here in the back, called the retina. This part here at the front, called the lens. And there's also a pupil here, and you probably know that the pupil regulates how much light gets let into the eye. And while it's got an important part, today I don't want to focus on that. And the other thing I'm going to draw, and I'm not going to do a very good job of drawing them, but these things here are called, I got to make sure that I say this right, ciliary muscles. And the point of ciliary muscles are so this is a sort of a squishy lens. And the point of the ciliary muscles are they can either squish that lens in or they can pull that lens out to change its focal point. Pardon me, so what I'm actually gonna do here is I'm gonna come over to my computer here and take a look at an animation, not that one. Yeah, so these are the ciliary muscles with the lens, and you can see that these can either stretch out that lens or they can squish it together. And it turns out when they squish it together, right, you're going to have a much closer focal point. And when it's stretched out, you're going to have a longer focal point, right? So that's what the ciliary muscles do. All right, let's get this set up again. All right. Okay, so the point of these ciliary muscles is the ciliary muscles stretch and squish the lens in order to change its focal length. And I'm going to show you here why this makes sense. Let me get it set up here. I've got kind of a jerry-rigged here thing here. But I'm going to take this again. And what I've done is I've got this piece of paper that I'm going to say this is your eyeball, right? Well, put the lens there in the eyeballs. Okay, so here's my eyeball, and there's your retina back here. Here are your ciliary muscles, and those ciliary muscles are bending and squishing it, and the way that I'm going to show that on this animation is they're gonna make that lens bigger and smaller, right? And this is something that is called the accommodation reflex, right? And here's where the accommodation reflex is important. So how do we see things? We see things because we have nerves on our eye that are sensitive to seeing things. So the nerves have names. They're called rods and cones. Rods help you see lightness and darkness. Cones help you see color. But where are these rods and cones? They're on the retina, right? So if I'm trying to look at this pencil over here, how can my eye see it? Well, I've got to get that light to hit my retina in order to see it, right? And so what has to happen here is you have this accommodation reflex, which is where your ciliary muscles, if I'm trying to look at this pencil, my ciliary muscles are going to squish that lens until that image is focused right here on the retina. Because now, right, this light here, it's activating the nerves on my retina and I can see it, right? If I want to look at something closer, my ciliary reflex has to work harder, right? And it's going to squish this lens even further together so that I can focus that object on the retina. But that's the idea, right? So you have your ciliary muscles that are squishing and stretching out that lens in order to change where the real image is being focused in your eye. And you want your real image to be focused on the retina. That's how you're able to see it, right? Yeah, you can kind of see, let me see here. If you, let me set this up so that you can see it for a second. If you hold two fingers in front of you, I'm sorry. If you hold this finger and then let's say you hold another finger there, right? And I can't do it and hold it at the same time. But if you've got two fingers and you hold it like right in front of your face, you can show that you've got the accommodation reflex because you can, sorry, I'm really trying to. If I got my two fingers here, right? If I'm looking at it, you won't be able to see it on the lens, but or on the screen, but you will be able to see it in front of you, right? If you hold those two things in front of your eyes, you can get yourself to focus on either the closer one or the farther away one, right? And that's your ciliary muscles squishing and stretching that lens so that either one comes into focus or the other one, right? Okay, so that's the idea of accommodation, right? Which is, I mean, it's really amazing that we can do this because without, like, we're usually even unaware that this is happening because we can look across the room and we can very quickly read something that's right in front of us, and it's all unconscious, and our ciliary muscles, the accommodation reflex, makes this happen. Okay, unless you've got a problem with your eye, right? So there are more than just two problems with your eye, but there's two that we're going to talk about today. One is the idea of nearsightedness, right? And so the nearsightedness is either there's something wrong with your eye in the sense that it's longer than it's supposed to be, or else there's something wrong with your ciliary muscles or your lens. So a lot of times people's eyesight gets worse as they get older because their ciliary muscles weaken, right? And they don't have as much control over what the focal length of this lens is. Okay. But what I want to do is I'm going to show you what happens if either because of your ciliary muscles or because of your eyeball is longer than your ciliary muscles can accommodate, right? And so we're going to imagine that I'm looking at a sign, the letter A on a sign way over here. I'm just going to draw a basic ray diagram, right? So our first ray, get a smaller ruler. Our first ray, just like we've been doing, is going to be parallel. Let me do it up here so that I can see it for sure. It's going to be parallel to the principal axis. And I'm going to hit that optical axis and then go through the focal point. Okay. I'm going to have another ray that's coming from the top of my letter A through the focal point, and then it gets refracted parallel to the principal axis. And then we have a third ray that should go right through the optical center, if I've done this right. Hopefully your image is a little bit better than mine, but what I've got is I have it's too small to draw, but right here you would have your real image of the letter A. But what's the problem? This image is not focused in the right place, right? When these rays get to your retina, right, they're not focused anymore. Let me draw this one too. Right? It's kind of like, let me go back over to my animation here. Where do I click here? If I click screen. It's kind of, well, here. It's kind of like this. Remember when you put the screen here, when the screen was too far back? the light didn't come into crisp focus. That's what's happening here, right? You see things in a blurry way when you're nearsighted. When you're nearsighted, things that are far away appear blurry because these rays of light aren't focusing at the right spot. They have to focus on the retina so that your optical nerves can pick it up. So how do we fix this? Well, to fix this, we put in a diverging lens. And it doesn't usually look like this. But if I put in a diverging lens, and I'm just going to kind of show with a different color what this is going to do, right? It makes some of these rays, instead of going straight in, they kind of diverge a little bit before they hit this lens. And if you get them to diverge the exact right amount, where are they going to focus? Hopefully, the goal is to eventually get them all to focus at your retina. Right? So what I've done with my diverging lens is I've taken rays of light that were converging too early and I've spread them out so that they hit the retina at the right place. So again, this is called nearsightedness. Nearsightedness is when you have trouble seeing far away. You have trouble seeing far away, and the reason is your eyeball is too long for your ciliary muscles. And for that reason, you can't focus on those images. And you correct this by wearing glasses that are diverging lenses. And again, this should make sense because if they were converging too quickly, if you pull them apart a little bit, that'll help them focus at the right point. I'm just going to show you real quick what happens if you're farsighted, right? If you're farsighted, that means that you can see things that are far away, but you can't see things that are near. I'm going to draw a diagram for this. Remember, even though that lens, or even though this ray of light doesn't actually enter the eye, as we were saying at the beginning on the previous video, I can still trace what it does because all of the rays of light follow the same rules. Oops. Don't have these going long enough. Get another one that goes parallel to the principal axis and through the focal point. So here's the problem with when you're farsighted, is your image, your real image, by letter A, the real image back here, is too far back. And once again, you can't get it to focus on the retina. So what are we going to do here? We're going to correct this by wearing glasses that are converging lenses. Because if I put on a converging lens, what it's going to do is it's going to take all of these rays of light and it's just going to converge them a little bit, just ever so slightly, converge them so that they come into focus here at your retina. So now my real image is there, focused at the exact right spot on my retina so that I can see things in focus. So when you're farsighted, you have trouble seeing close objects. Your eyeball is too short for your ciliary muscles. Too short. And the glasses that you need to correct this are converging lenses. So anyway, that's just sort of an interesting application of the optics to lens correction, to this idea of the accommodation reflex. With any remaining time, again, you still have the 3 things you were working on yesterday you can still work on. Your syllabus should be almost done. And I'll take questions over your syllabus tomorrow. Your lens labs should be almost done. And if you're done with all that, you can work on your final exam review. All right, have a good day.